Hello everybody, this is Mr. Pickard and I'm going to talk to you today about trigonometric ratios. We can see this is Tennessee Standard G.SRT.C4. Use side ratios and right triangles to define trigonometric ratios. The purpose of this is to teach 10th grade geometry students about trigonometric ratios. The reason that I chose this is that it was agreed upon by my geometry teammates. It's a topic I enjoy and I am quite passionate about. It's one of my favorite things to teach, and we're going to be teaching this in the near future. So, very practical as well. All right, the objectives of this lesson. By the end of this lesson, you will be able to identify and label the hypotenuse and legs in a right triangle. Identify and label opposite and adjacent legs given an acute angle in a right triangle. Determine the ratio of a given trigonometric function. First, let's review about labeling triangles. As we know, the vertices or the points of triangles are always labeled with capital letters, as we can see here, A, B, and C. In addition, the sides that are opposite the vertices are labeled with corresponding lowercase letters. For example, opposite angle A will be side A, lowercase a. Opposite angle B will be side, lowercase b. And opposite angle C will be side, lowercase c. Right triangles are made up of three sides, just like any triangle. The side that is opposite the right angle, meaning across from the right angle, is called the hypotenuse. The other two sides that form the right angle are called the legs, and we will have two of those. I would like you to take a moment, pause the video, and determine what you think the hypotenuse is of each triangle below. Hopefully you've made your determination at this time. If you said, oops, I clicked back. If you said A on the first one, you would be correct. If you said E on the second one, you'd be correct. And hopefully you said J on that last one. So what is trigonometry? Trigonometry is a study of relationships between side lengths and angle measures of triangles. There are three primary trigonometric ratios that we're going to talk about today. The first one is the sine function. Sine is always going to be the ratio of the leg opposite the reference angle to the hypotenuse. So what do I mean by reference angle? So they're going to ask us to find either sine of A or sine of B in this example. So sine of A is going to be the ratio of the leg opposite the reference angle to the hypotenuse. So A is going to be our reference angle here. So we'll put a little arc there to indicate that. And remember, we have two legs in a right triangle. So we got to have a way to differentiate them because we want the leg that is opposite the reference angle. In this case, A, lowercase a, is the leg opposite that reference angle. To the hypotenuse, always opposite the right angle, so that's going to be C. So our ratio of the leg opposite A to the hypotenuse C will be A over C. They could have also asked us to find sine of B. In that case, B is our reference angle. Sine is the leg opposite, so in this case that's lowercase b, to the hypotenuse C. So sine of B will then be B over C. And that's our sine. ratio. Our second trigonometric ratio, or trigonometric function, is cosine. Cosine is the ratio of the leg adjacent to the reference angle to the hypotenuse. Again, they could ask us for cosine of A or cosine of B. Our reference angle for the first one, cosine of, clicked back by accident, sorry about that. Our reference angle of A, cosine A is A. A is then our reference angle. This time it's going to be the leg adjacent to the hypotenuse. So in this case, it'll be B over C for cosine of A. If they ask us for cosine B, B then becomes our reference angle. It's still the leg adjacent, but in this case, the leg adjacent is A to the hypotenuse C. So it's A over C. Our third and final trigonometric function is tangent. Tangent is always going to be the ratio of the leg opposite the reference angle to the leg adjacent. We could be asked for tangent of A or tangent of B. Tangent of A makes A our reference angle, and it's the leg opposite, so it's A, to the leg adjacent, B. So tangent of A will be A over B. If they ask us for tangent of B, all of a sudden B is our reference angle, and it's going to be opposite over adjacent. So B over A. Now, that's a lot of information to try and remember. And so we have a mnemonic or acronym of SOHCAHTOA. SOHCAHTOA is our way to help us remember these three ratios. Right? Sine is opposite over hypotenuse, SOH. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, CAH. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, TOA. So I would highly recommend you memorize that acronym, how to spell it, so you can remember the three trigonometric ratios. All right, it's your turn to practice these. If you go to the website here, student.amplify.com/join/KTAZFG, you will find multiple practice problems. You can practice as much or as little as you like to feel comfortable with today's lesson. Once you have done so, we're going to go to a check for understanding that you will then submit to me on a Google form. And you will go to the link below to complete that Google form as your exit ticket. Well, that's all I have. I hope this helped you better understand trigonometric ratios, how to identify those hypotenuse and legs of right triangles, and of course, which leg is opposite versus adjacent. Have a great rest of your day.